Alcohols, ठीक है. Alcohols में we studied के OH functional group होता है. ये उसका general formula था, which most of the time doesn't really work. और मैंने कहा था कि it's only the OH functional group. These are not alcohols. कि if there's a benzene, अच्छा ये खास तौर पे ख्याल रखना कि if there's a benzene and it has OH with it, that's not an alcohol. Although ये आपके कोर्स में नहीं है, अभी नहीं है. AS के कोर्स में नहीं है. A2 में it's in your course. Carboxylic acid is also not an alcohol. Achha, melting and boiling points are relatively higher because they have hydrogen bonding between them. They're very soluble in water, and I told you that solubility decreases with size. Because if there's a bigger molecule, तो उसमें ना this non-polar side chain is not going to attract water. So the solubility or the water attracting part would be relatively smaller in a bigger molecule. So solubility decreases with size. Uh, Now the next part is we're going to move towards chemical reactions of alcohols. Now, the first thing is we're going to talk about the formation of alcohols. And when we talk about formation of alcohols, usme the first reaction, a few of the reactions have already been studied. So, as a formation of alcohols. One was number one, hydration of alkenes. This one was already studied in alkenes. If you have an alkene, so an addition reaction would take place. Water is going to get added. Conditions these ki you needed phosphoric acid as catalyst, and you needed a temperature of 300 degrees centigrade and a pressure of 60 atmospheres. Or एक जगह पे ना there's going to be H added, double bond would break, and it would change into so the double bond would break, and एक जगह पे H, and the other side it's going to be OH. That's going to be added. That would result in the formation of an alcohol. There was the Markovnikov's rule, जिसमें था कि उसमें था कि H and OH, they usually get added to H gets added to carbon, which is already bonded to more hydrogens. Second reaction. The second reaction is that it was nucleophilic substitution. Nucleophilic substitution that we just did recently, Sn1, Sn2. Of halogenoalkanes. As a nucleophilic substitution of halogenoalkanes, in this case, you had OH wala nucleophile. If you have a halogenoalkane and it has a chlorine or a bromine or any halogen that's attached to it, so the carbon is positive, the Cl is negative, and if the OH minus 1 nucleophile is added, and that is added when you add NaOH aqueous and reflux. So if you add that, the result would be the Cl would get substituted by OH, and that's it. And the Cl minus 1 would get knocked out. This was nucleophilic substitution, Sn1, Sn2. We did this in detail. Now, the third method of preparing a halogenoalkane is fermentation. Okay, O levels mein padha tha. Okay, industrially, what you do is you ferment, and you ferment glucose. Okay, you ferment glucose. Glucose is the equation for the reaction would be that glucose is C6H12 O6, and it would form C2H5 OH plus CO2। अच्छा, इसमें है कि yeast is added as a catalyst. Temperature is usually kept around the temperature is kept around 25 to 35 degrees centigrade. And the other thing is 25 to 35 degrees centigrade and uh, absence of air. Yeah, O2 specifically. This is anaerobic conditions. Okay, so you have these, you use anaerobic conditions for this reaction. Minal, clear है? Ariba, clear है? ये O levels का reaction है.
जी।
अच्छा, इसमें होता है कि दो तीन मसले इसमें, ठीक है. वेरी स्मॉल, वेरी लो यील्ड. ठीक है. Why? Because जैसे ही alcohol produce होगा ना, it's going to, this alcohol over here is going to kill the yeast. क्योंकि alcohol antibacterial होता है, ठीक है, ये it's an antibacterial, antiviral substance, and it ends up killing the yeast. So alcohol produced, it ends up, it kills the yeast. तो थोड़ी सी percentage से, मतलब 5 to 8%, that's the amount of alcohol that's going to be produced before it ends up killing the yeast, and the reaction would eventually stop. Here the other thing is it's you can't use higher or lower temperatures. So you can't use higher or lower temperatures as so what it does is, as it also denatures yeast. Okay, as it denatures yeast. And क्योंकि it's a biological substance, higher temperature वैसे ही मर जाएगी, lower temperature पे it's going to be inactive. But at lower temperature it's going to be inactive. So then the thing is that alcohol produced is distilled off. It is removed from the mixture via distillation. Okay, so you distill off the alcohol that's been produced. So that's number 3. अच्छा, ये सारा तो आप पहले ही कर चुके हैं, और इसमें there's another point which is कि if air is present, so if air is present, so because of the air, the alcohol will get oxidized into carboxylic acid. I say it gets oxidized into carboxylic acid, and that makes it very deadly as well. तो ये सारा है. अच्छा, ये fermentation of glucose है, that's over. इससे ज़्यादा तो खैर nothing would be asked. Let's move to the more important reactions of alcohols. पहले सबसे important reaction पढ़ लेते हैं. One of the most important reactions of alcohols is that alcohols get oxidized. ठीक है, so oxidation of alcohols. And what do you use for oxidation of alcohols? You use the reagent that's used, reagent बाद में discuss कर लेते हैं. I'll talk about उसी के ऊपर chart के ऊपर I'm going to write the reagent. There are three types of alcohols. One is a primary alcohol. Then you have your secondary alcohol. And then you have your tertiary alcohol. Okay, so there are three different types of alcohols. Primary is जिसका उसमें था, primary में OH होगा, and the carbon is going to have two hydrogens, and on one side there's going to be a carbon chain, just on one side. Secondary would be that the OH carbon atom, on two sides they're going to be carbon chains, and on one side there's going to be hydrogen. And the third one is on three sides they're going to be carbon chains. Okay, so you have primary, secondary and tertiary alcohols. जैसा उसमें mechanisms में होता था, halogenoalkanes में also had primary, secondary and tertiary alcohols. Miral, clear है? Reba, is this clear?
जी.
So इसके पहले the first thing, just a few examples. Okay, let's say I have a molecule. So there's an OH here. कौन बताएगा? Reba, can you tell me which alcohol is this one, the first one? ये वाला. Is this primary or secondary or tertiary? मतलब इस कार्बन पे फोकस करो, इस कार्बन के ऊपर. मिनाइल क्या होगा? रीबा?
Primary.
ठीक है, प्राइमरी है क्योंकि इसके साथ there has to be bonds उसके पूरे करने के लिए स्केलेटल फॉर्मूला है, there has to be two, they've got to be two hydrogens. ठीक है, तो इसलिए this is primary. Only one carbon chain. What about this next one? मिनाइल क्या होगा ये?
Secondary.
नहीं, उसके carbon chains इस side में भी there's carbon chain, this side there's also a carbon chain, on the third side there's carbon chain as well. So this one would be tertiary. ये वाला primary था. Clear है मिनाइल? Ariba, is this clear?
Yes.
अच्छा, फिर last one is this one. Ariba, क्या है ये? Which type of alcohol?
Secondary.
ठीक है, this is secondary क्योंकि this carbon atom is bonded to two carbon chains, which basically means there's going to be a hydrogen somewhere. A fourth bond would be with a hydrogen. So this one is secondary. ठीक है, ये clear है दोनों को? मिनाइल, is this clear? Ariba, clear है? Primary, secondary, tertiary.
Yeah.
अच्छा, now in O levels you studied oxidation of alcohols, but remember now the oxidation of alcohols, like the oxidation of alkenes. Alkenes भी थोड़ा complicated था कि उसके अंदर ना different scenarios होते हैं. You had alkenes breaking off, and उसी तरह alcohols, when they get oxidized, there would be different scenarios. The first one is, if you oxidize a primary alcohol, the primary alcohol changes into it changes into an aldehyde first. And that aldehyde then changes into a carboxylic acid. It it then changes into a carboxylic acid. So you have this diagram, okay? That's the process of oxidation. Remember forward direction where this is oxidation happening. Now there are many different reagents that you could use to oxidize. For example, primary alcohol to aldehyde. That's going to be acidified K2Cr2O7 and reflux. ठीक है, reflux का मतलब है you'll put a condenser on top so that the alcohol doesn't evaporate. And also remember KMnO4 could also be used. But the preferred one is K2Cr2O7, the dichromate 6. ठीक है, that's the preferred one. I said then same thing for aldehydes. Aldehydes can also get oxidized. And they're going to use K2Cr2O7, acidified, and reflux. ठीक है, that could be used. या फिर you could use other substances as well. There's tolerance reagent. इसको बल्कि नीचे लिखते हैं. A second one could be tolerance. I said tolerance reagent is Ag, NH3 twice, and +1. ठीक है, it's basically this whole thing is basically silver nitrate, aqueous mixed in ammonia. It's silver nitrate aqueous plus NH3 aqueous. What happened is in this case Ag+1 वो oxides हो रहे हैं तो Ag+1 gets reduced. And if it gets reduced, it gets reduced to silver. So one of the key observation is that silver mirror is formed. And simultaneously a black precipitate is formed. And so these two things happen when you use tolerance reagent. ठीक है, मैं भी एक दफा ही फिर दोबारा एक्सप्लेन करूंगा कि ऐसे K2Cr2O7 के ना कलर चेंजेस भी याद होने चाहिए. It's going to be orange too. As it's going to be orange to green. Anyways, these are the oxidizing agents, ठीक है, that will oxidize aldehydes to carboxylic acids. The chain is primary alcohol gets oxidized to aldehyde and then gets oxidized to carboxylic acid. Tolerance reagent is silver ions basically. This one is known as a complex ion. ये जो चीज यहाँ पे बनी है, that's a complex ion. Complex ion होता है कि silver nitrate को if you mix it in NH3, the solution में ना there are Ag+1 ions that are roaming around. So NH3 has these lone pairs. So a bunch of NH3 molecules in the solution would get attracted to the positive ion and they're going to bind with it. They're going to form dative bonds with them. And that results in the formation of this complex ion. complex ion is not in your course. ठीक है, not right now. A2 के course में. But remember what how silver AgNH3 twice. This complex ion is formed. Okay, solution के अंदर silver ions they start all the NH3s they start sticking to it. तो ये पूरा एक ना चीज बन जाती है. ये क्लियर है? मिनाइल क्लियर है? रीबा इज दिस क्लियर?
जी.
अच्छा खैर, what you just need to remember is कि when this gets oxidized, this aldehyde changes into carboxylic acid. Simultaneously, the silver ions they get reduced to silver, which is why silverish mirror is formed on the top of the screen of the solution. But I'll give you an example. कि Tollens. So there's going to be a I said this probably shows this very clearly. What you can see is a silverish mirror type surface that's forming in the flask. If you can see this, zoom in नहीं हो रहा, but you'll get an idea of what's happening. Okay, let me see a better picture. ये चलो अच्छी है. इस तरह करके ना वो silverish थी ना, वो silver deposit जब होगा ना, silver is shiny. ठीक है, so it's going to form a deposit like that. Is this clear? Minail clear है? Reba clear है?
Yes. जी.
अच्छा, so aldehydes they get oxidized. ठीक है, I'll rub this off. Then there's a third way of oxidizing aldehydes to carboxylic acids, and the third one is filling solution. Actually, now what's the filling solution? You had K2Cr2O7, you had tollens, and you had filling. Filling solution is also known as Benedict solution. It's copper 2 plus ions in the solution, blue colored, and they get reduced. I said they get reduced to mic on. I said they get reduced to copper 1 plus or copper 1 oxide. So they get reduced to red precipitate of copper 1 oxide. ठीक है, so there's इसको भी दिखा देते हैं कि what would the filling solution look like. As the filling solution is blue, ठीक है, it's like copper sulfate. And it's going to form red precipitate. So that's basically the blue color changes to red when this reaction happens. Okay, that's the red precipitate. So K2Cr2O7. And that's why I repeat. 3 totally different reagents when you want to oxidize an aldehyde to carboxylic acid. K2Cr2O7 tollens or Felling solution. Remember the words tollens and Felling and what they do. They oxidize aldehydes to carboxylic acid. Or is your first pair, let me bring it down as well. To oxidize and remember KMNO4 can also be used, but KMNO4 is not preferred. Reason it's not preferred is it's a very strong oxidizing agent, तो बहुत सारी different चीजों में convert हो जाता है. अच्छा क्या, we haven't done the reaction. एक example कर लेते हैं reaction का कि if I have a primary alcohol, ठीक है, I'm going to draw it above this. If I have a primary alcohol would look like this. Okay, there's OH and the carbon is bonded to 2 hydrogens. This one would be CH2 and this one would be CH3. So this is your normal alcohol, primary alcohol. It's going to first change into an aldehyde. What's an aldehyde? तो जो N वाला पार्ट नहीं है, that would change into an aldehyde. It's double bond O and H. अच्छा, ये जो N वाला part है, that changes into aldehyde, and it would further get oxidized to a carboxylic acid. ठीक है? Is this clear? कि आपने ना वो जो अल्कोहल वाला पार्ट नहीं है, ठीक है, जिसको मैं हाईलाइट कर रहा हूँ, only that part. It first is an alcohol, a primary alcohol. It then changes into an aldehyde. ठीक है, so it changes into an aldehyde, and which then further gets oxidized to a carboxylic acid. मिनाइल, अरीबा, ये क्लियर है?
Yes. जी.
अच्छा, मुझे बताओ कि if I add acidified K2Cr27 and reflux, will the reaction stop at aldehyde or will it continue to carboxylic acid? क्योंकि अगर ये देखो ना कि aldehyde to carboxylic acid, it's the same reagent that's needed. मतलब the first two reagents are they're exactly the same. तो इसका मतलब है कि the reaction would most likely it never stops at aldehyde. हमेशा क्या होता है अगर primary alcohol को oxidize करोगे, so it would change into an aldehyde but then quickly change into a carboxylic acid. Ariba, Minail, is this also clear?
जी.
अच्छा, तो ये important point है कि the reaction usually does not stop at aldehyde, and it gets further oxidized to carboxylic acid. As it gets further oxidized to carboxylic acid. अच्छा, लेकिन what if you want to stop it at aldehyde? अच्छा, reflux का क्या मतलब है? Reflux का मतलब है कि कोई भी चीज ना इस कंटेनर में से ना बाहर नहीं निकलेगी. There's going to be a condenser on top. Anything that evaporates would fall back into it. अच्छा, if you want the reaction की reaction primary alcohol से changes to aldehyde and you want to stop it there, तो क्या करना होगा? Immediately aldehyde must be taken out. So what you do is कि to stop the reaction at aldehyde, अच्छा, so to stop the reaction at aldehyde, instead of reflux, use distillation. Reflux तो prevent करता था, कोई मतलब it would not allow anything to escape. So instead of reflux, use distillation. और होगा ये कि aldehydes का ना compared to alcohols, they have lesser boiling point क्योंकि aldehydes don't form hydrogen bonds. तो aldehydes have lower boiling points as they don't have OH groups. As they don't have OH groups or form hydrogen bonds. Hence, they evaporate and escape the mixture. ठीक है, is this part clear? Ariba, Minhail, is this clear?
Yes. जी.
तो याद रखना कि अगर तो रिफ्लक्स कर रहे हो तो रिफ्लक्स में तो कोई चीज बाहर निकल नहीं सकती. रिफ्लक्स था क्या? What was the reflux apparatus? के reflux was नहीं केमिस्ट्री वाला रिफ्लक्स. अच्छा, रिफ्लक्स was कि आपने ना टॉप पे कंडेंसर लगाया हुआ था, ठीक है, सो दैट नथिंग एस्केप्स. नाउ यू गोइंग टू टेक ऑफ द कंडेंसर. तो बीच में जैसी एल्डिहाइड फॉर्म होगा, इट डजंट फॉर्म हाइड्रोजन बॉन्ड्स, तो इट विल इवेपोरेट वेरी इजीली. तो यू कैन टेक इट आउट. तो वो आगे कार्बोक्सिलिक एसिड में ना ऑक्सीडाइज नहीं होगा. अच्छा, दैट्स द ऑक्सीडेशन ऑफ प्राइमरी अल्कोहल्स. देन यू हैव द ऑक्सीडेशन ऑफ सेकेंडरी अल्कोहल्स. अच्छा, फर्स्ट हो गया सेकेंडरी अल्कोहल्स इज कि उसमें क्या होता है. इफ यू हैव अ सेकेंडरी अल्कोहल, they would get oxidized to ketones. That's it. And the reagent that would be used would be acidified K2Cr2O7 plus reflux. Remember that ketones don't get oxidized. Ketones are very stable to oxidation. That's one of the major differences between ketones and aldehydes. As a major difference के ऊपर aldehydes were getting oxidized, ketones don't. So this is one of the major differences between अच्छा तो हुआ क्या है कि primary alcohol पहले aldehyde थे, carboxylic acid, secondary alcohol, it just simply goes to ketones, that's it. और इसमें भी ये कि KMNO4 could also be used, but usually not preferred. I said then after this there's a third reaction, and the third reaction is tertiary alcohols. उनकी oxidation नहीं होती. अच्छा, इसका एग्जांपल कर लेते हैं पहले कि let's think of an example कि secondary alcohol. Secondary alcohol could be कि you have 3 carbon atoms. So if you look at this molecule, it's on two sides there carbon chain, on one side there's H. तो आगे जाके क्या हो जाएगा, ये जो कार्बन आटम बीच वाला कार्बन आटम नहीं है, that would change into a ketone. That's it. यानी all the changes, remember बाकी molecule को कुछ नहीं होना चाहिए, all the changes would happen to this carbon atom over here. जो OH वाला carbon atom है, that is the one that's going to change. मेरा clear है ये, अरीबा?
Yes. जी.
अच्छा, now tertiary alcohols पे आ जाते हैं. Tertiary alcohols का simple है, they simply don't get oxidized. अच्छा, tertiary alcohols simply don't get oxidized. That's it. तो यहाँ पे प्राइमरी, सेकेंडरी और टर्शियरी अल्कोहल्स तीनों की ऑक्सीडेशन है, ठीक है. रिमेंबर इसमें हमने एल्डिहाइड की भी ऑक्सीडेशन कवर कर लिया है. वी हैव कवर्ड कि एल्डिहाइड किस तरीके से ऑक्सीडाइज हो सकता है. सो नाउ वी गोइंग टू डू सम क्वेश्चंस, ठीक है. आई एम गोइंग टू ड्रॉ अ रैंडम मॉलिक्यूल और उसके एग्जांपल्स करते हैं. अच्छा, the examples are कि let's say I have a molecule and there's OH. अच्छा, ये molecule है, ठीक है? This is the molecule in front of me, and I want to figure out what's going to happen if I oxidize this. ठीक है? Let's say I'm heating it with acidified K2Cr2O7 under reflux. ये कौन सा अल्कोहल है? ये कौन सा अल्कोहल है?
Primary.
ठीक है, this is primary. तो primary जो है ना, that's going to change into a carboxylic acid. Remember that. मिलाइल, ये कौन सा अल्कोहल है?
Primary.
नहीं, इसके साथ कितनी कार्बन चेन अटैच्ड है? इस कार्बन के साथ how many carbon chains does it?
Second.
ठीक है,
Secondary.
secondary. और ये
Tertiary.
ठीक है, this one is tertiary. अच्छा, now आपने पूरा मॉलिक्यूल उसी तरह बनाना है, ठीक है? Nothing should change. So that is what I'm going to do. I'm going to draw the entire molecule again. अच्छा, ये molecule है. यहाँ पे OH था ना, this carbon atom. What would it change into? Carboxylic acid. So it's going to become C double bond O and OH. अच्छा, what about there was an OH on this carbon atom over here? ठीक है, ये ऊपर OH होता था. This would change into, it's a secondary alcohol, it would change into a ketone. Or you had a tertiary alcohol which was lying somewhere over here, nothing would happen to it. Okay, so you got a carboxylic acid. And you got a ketone. And you had a tertiary alcohol that did not get oxidized. Is this clear? Minahil, Reba, is this clear?
Yeah. G.
तो काम करो, ये दो क्वेश्चंस रख लो. Question number 1 is, इसको ऑक्साइज करो. And question number 2 is, this is question number 2. इन दो मॉलिक्यूल्स को ऑक्साइज करो. पहले तो लेबल कर लेना, प्राइमरी, सेकेंडरी, टर्शियरी, एक्सेट्रा. And then send me the answers. ये कोशिश करो मुझे भी भेजो व्हाट्सएप पे.